Imagine standing on a cold, gray piece of rock, deep in the wilderness. It looks ordinary, worthless even. But beneath your boots lies a multi-million-dollar secret, a literal window to the center of the earth. Most people would walk right past it. They would see nothing but a crumbling, volcanic stone. But professional prospectors know better. They know that certain bizarre, ancient volcanic rocks are the only vehicles on Earth, capable of carrying diamonds from the deep mantle up to the surface. If you know what to look for, these 6 stones tell you exactly where the ultimate treasure is hidden. Don't walk away. Today we unlock the geological signatures of the world's most lucrative diamond deposits. Diamonds do not belong on the surface of our planet. They are alien to the world we live in. To build a diamond, you need 2 things, pure carbon and an unimaginable amount of violence. Think about it. 100 miles beneath our feet. The pressure is over 700,000 pounds per square inch. The temperature? A blistering 2,000 degrees Fahrenheit. This is the only place where carbon atoms can be crushed tightly enough to form the hardest material in the universe. But there is a catch. If a diamond travels to the surface slowly, it dies. As the pressure drops, the diamond transforms. It destabilizes. It turns into graphite. Yes, the lead in your pencil. To survive the journey, a diamond needs a cosmic elevator. It needs a volcanic eruption so fast, so explosive, that it breaks the sound barrier. A supersonic blast of gas and magma that tears through the Earth's crust in a matter of hours. When that magma cools, it leaves behind specific, highly unique volcanic rocks. These are the rocks we are hunting today. And the first one on our list changed global history forever. Kimberlite. Miners call it the blue ground. In 1867, a 15-year-old boy found a shiny pebble on the banks of the Orange River in South Africa. That pebble was the Eureka diamond. It kicked off the greatest diamond rush in human history. When miners dug deeper, they discovered that diamonds were trapped inside a strange, dark, greenish-blue volcanic rock. Look closely at this stone. When it is fresh from the ground, it has a distinct dark blue-green hue. But when it sits in the sun and rain for a few years, it weathers. It turns into a soft, crumbly yellow clay called yellow ground. If you are walking through an old volcanic field and you notice the soil suddenly shifts, from standard brown dirt to a strange circular patch of yellowish, clay-like soil, stop. You might be standing directly on top of a kimberlite pipe. Kimberlite is not just a rock, it is a messy soup. As the magma blasted upward from the mantle, it ripped apart everything in its path. It grabbed pieces of the mantle, it grabbed crustal rocks, it grabbed ancient fossils. When you hold a piece of kimberlite, you are holding a geological mosaic, and buried deep inside that mosaic are raw diamonds. But how do you find these pipes if they are buried under hundreds of feet of dirt and forest? The secret lies in the crumbs left behind, the indicator minerals. Diamonds are incredibly rare. Even inside a rich kimberlite pipe, they make up less than 1 part per million of the total rock. Finding a diamond directly in the field is like winning the lottery twice in one day. So how do professional geologists find them? They don't look for diamonds, they look for their bodyguards. When a kimberlite pipe erupts, it brings up massive amounts of deep mantle minerals alongside the diamonds. These indicators are tough, they are brightly colored, and they survive the harsh forces of erosion. The most famous of them all? Pyrite garnet. But these aren't your typical jewelry store garnets. These are chrome pyropes. Because of the high chromium content deep in the earth, they glow with a deep, mesmerizing, blood-red hue. Beside them, you will find chrome diopside, an indicator mineral so bright it looks like neon green glass. Imagine panning in a mountain stream. You wash away the silt. Suddenly the sun hits your pan, and you see flashes of brilliant blood red and emerald green scattered among the dull gravel. Your heart stops. You haven't found a diamond yet, but you have found their calling card. The closer you get to the source, the larger and more angular these crystals become. Follow the trail upstream, and it will lead you directly to the volcanic throat. This brings us to rock number 2, lamproite, the hidden rebel. For over a century, geologists believed in absolute rule. Diamonds only hide in kimberlite. It was written in every textbook. It was accepted by every major mining corporation on Earth. But geology loves to break its own rules. In the late 1970s, prospectors in the remote Kimberley region of Western Australia found something that shocked the scientific community. They found diamonds. Billions of dollars worth of diamonds. But there was no kimberlite anywhere to be found. Instead, the diamonds were trapped inside an entirely different type of volcanic rock. Lamproite. Lamproite is a weird, chemically bizarre volcanic stone. It is rich in potassium and magnesium. Unlike kimberlite, which forms neat carrot-shaped vertical pipes, lamproite behaves differently. It erupts like a bubbling cauldron, spreading out across the surface into wide, shallow, mushroom-shaped structures. This single discovery led to the opening of the Argyle diamond mine. For decades, Argyle produced more diamonds by weight than any other mine on the planet. It was the world's primary source for the rarest, most expensive gems in existence. The ultra-rare Argyle pink diamonds, all found inside a rock that experts claimed could never hold them. Think about that. An entire empire built on a rock that shouldn't exist. But here is where the mystery deepens. Kimberlite and lamproite are just the beginning of this treasure map. There are 4 more volcanic signatures out there. We already know that diamonds require extreme, violent volcanic eruptions to escape the deep earth. But to find the ultimate jackpot, you have to understand exactly where these volcanoes choose to punch through. They don't just appear anywhere. They target the oldest, most stable cores of our continents, areas called cratons. Look at a map of the world's richest diamond mines. You will notice a stark pattern. They are located in places like northern Canada, Siberia, Western Australia, and southern Africa. What do these places have in common? They sit on pieces of the Earth's crust that have remained completely undisturbed for over 2.5 billion years. These ancient continental blocks are the cratons. Think of a craton like a massive iceberg. The part we see on the surface is just a fraction. Below the surface, the craton extends deep into the mantle like a massive rocky keel. Geologists call this the cratonic root. This root is incredibly thick. It acts like a giant thermal blanket, keeping the mantle beneath it cool enough and pressurized enough for diamonds to remain stable for billions of years. If a kimberlite volcano erupts through young, thin crust, like in California or Europe, it will be empty, sterilized. The diamonds were never there to begin with. But if that same volcano punches through an ancient cratonic root, it acts like a giant vacuum cleaner, sucking up billions of carats of ancient diamonds and delivering them right to the surface. This brings us directly to our third rock, a stone that is so heavy and so colorful, it looks like it belongs in an art museum rather than a muddy prospecting pit. Eclogite. Eclogite is beautiful. It is a striking mixture of Christmas green pyroxene and fiery orange-red garnet. But to a diamond hunter, its beauty is secondary to its origin. Eclogite does not form in the crust. It is a metamorphic rock born deep inside the upper mantle. It is actually the remnants of ancient oceanic crust, pushed deep into the earth billions of years ago through subduction. As it sank, the immense pressure transformed the minerals into this ultra-dense, green and red masterpiece. When a kimberlite pipe explodes upward, it breaks off chunks of this deep eclogite and carries them along for the ride. These chunks are called xenoliths, which literally means foreign stones. If you are examining a volcanic formation and you find a dark rock with rounded foreign lumps of bright green and red embedded inside it, you have just found an eclogite xenolith. Why is this a complete game changer? Because eclogite is one of the absolute primary host environments for diamonds. In fact, diamonds found inside eclogite are famous for their exceptional clarity and massive size. You are looking at a literal piece of the diamond factory itself. Our next 2 rocks represent the twin faces of a diamond volcano, the deep source and the explosive surface aftermath. Rock number 4 is peridotite, specifically a variety called garnet peridotite. This is a dense, heavy olive green stone made mostly of a mineral called olivine. Just like eclogite, peridotite makes up the vast majority of the Earth's mantle. When you find chunks of pale green, sugary textured peridotite inside a volcanic pipe? It proves the volcano came from the absolute maximum depth required to carry diamonds. But what does the volcano look like at the surface? That brings us to rock number 5, kimberlitic tuff. When the supersonic diamond volcano finally reached the surface billions of years ago, it didn't flow like a quiet lava stream. It exploded into the atmosphere like a colossal shotgun blast. The air was filled with ash, shattered rocks, and pulverized diamonds. This debris rained back down into the volcanic crater, compacting over millions of years into a soft, porous, layered rock called tuff. To an untrained eye, kimberlitic tuff looks like cheap gray concrete. It looks completely uninteresting, but look closer. It is packed with tiny, fractured crystals of olivine, sparkling mica flakes, and broken mantle fragments. Because it forms the top crater portion of the pipe, it is often the very first rock a surface prospector will encounter. If you clear away the topsoil and find a soft, gray, concrete-like rock filled with green and red mineral fragments, don't walk away. You have found the top of the pipe. Finally, we reach rock number 6, the ultimate wild card of the geological world. Carbonatite. Almost all volcanic rocks on Earth are silicate rocks, meaning they are made mostly of silicon and oxygen. But carbonatite is bizarre. It is an igneous rock made almost entirely of carbonate minerals, like calcite and dolomite. It is essentially liquid volcanic limestone. When it erupts, the lava is not glowing red. It is a strange, dark brown or black liquid that flows like cool mud, hardening into a stark, whitish-gray rock within minutes. For a long time, carbonatites were completely ignored by diamond hunters. They were mined for rare earth elements, niobium, and phosphates. But recent discoveries have revealed a shocking connection. Because carbonatites are loaded with carbon, the raw material needed to grow a diamond, they often form in the exact same deep mantle pathways as kimberlites. In some rare localities around the globe, carbonatite complexes have been found to host microdiamonds, and they act as a direct geological signpost for massive, nearby diamond-bearing systems. It is the final piece of our 6-rock puzzle. The Earth never openly displays its greatest treasures. It buries them. It hides them behind billions of years of erosion, dense forests, and deep oceans. But it always leaves a trail, whether it is the blue-green matrix of kimberlite, the rule-breaking structures of lamproite, the stunning green and red mosaic of eclogite, or the bright, unmistakable calling cards of blood-red garnets and neon green diopsides. These rocks are the ultimate roadmap to the deep. The next time you're out in the field, look closely at the stones beneath your boots. Don't just see rocks, see the story they are trying to tell you, because true wealth is waiting for those who know how to read the geological signature. Which of these 6 volcanic rocks surprised you the most? Have you ever found an indicator mineral in your local rivers? Let us know in the comments below. We read every single one. If you want to master the art of professional prospecting and unlock more deep earth secrets, hit that subscribe button right now, turn on notifications, and give this video a thumbs up.